Assalamualaikum and good days everyone. I'm Aidil.
Hi, I'm ZAWAWI Muhammad Zubair.
Hmm.
Hello, I'm MUZHAFFAR.
Hi everyone, I'm IZZATI.
At the beginning of semester, we were assigned by our lecturers to come up with CMOS layout design based on selected Boolean equation. So in order to get this done, we decided to follow EDP. EDP, Engineering Design Process, is a series of steps that engineers follow to come up with a solution to a problem. This is the exact approach that we use as a theme for our mini project. It consists of some steps which are to define the problem, to gather information, to brainstorm ideas, to select the best one amongst the idea, to develop the prototype of it, to test the project, and finally to refine and improve if needed be. Let's get to the first one, which is to define the problem. The specifications are it should consist of a minimum of 12 transistors involved. Second, it should be somewhat applicable in real life. Finally, it should be related to United Nations Sustainable Development Goals (SDGs). So what we did is each one of us proposed one project that fulfills all of the criteria just now. We had automated watering project, burglar system, smart home security system, and automated light control system. Through EDP4 process, we used the smart table to determine whether each of the project proposed is specific enough, measurable, actionable, realistic, and time-bound. We also used the SWOT table to analyze each one of us in terms of strengths, weaknesses, opportunities, and threats. So after a while, we decided as a team to design an automated watering project. Why, you may ask? The weather nowadays is increasingly hot, isn't it? It's not just affecting us, but also negatively affecting the plants as well. Plants may wilt due to the loss of water faster than they can absorb it from the soil. With this project, we could reduce those effects. And the best part is the project is related to SDG 15, Life on Land, SDG 13, Climate Action, and fulfills all the prerequisites.
After thorough research, it is found that the project needs at least 4 sensors to function as intended. Sensor A to check the surrounding temperature, Sensor B to detect the surrounding humidity level, Sensor C to measure the intensity of light in its environment, and finally Sensor D to check the soil moisture level. The Boolean expressions are as follows: y equal to a plus b c d bar. It can be seen that the output is only activated under the three conditions. Firstly, when A0, B1, C1, D0. Secondly, when A1, B0, C1, D0. And finally, when A1, B1, C1, and D0.
At this point of EDP, which is to brainstorm idea, each one of us come with a sketching of schematic plus illiput diagram, stick diagram, and layout with DRC associated with it.
Now is the time to evaluate each one of the proposed Euler path, state diagram, and layout with the RC chart. We did this by using an evaluation table that compares each one of the Euler path, state diagram, layout, and design rules chart. Finally, we made a decision as a group to proceed with the Aidil's proposal. Here, we started to design the sketch schematic on Mentographic. Unlike in sketch schematic, where we did not specify the connection for body of all the MOSFET, in Mentographic, we had to configure them. We have one inverter in the input side and one inverter at the output side. After we have completed the schematic, we move on to set up the test bench. We have set all the necessary connection to our block diagram and set the input voltage. Each of the input voltage was set with different width and period to achieve a generated waveform that could be compared with truth table to further verify the design. And finally, we have designed our layout in Mentographic according to sketch version of it and following the rules defined in the sketching.
Moving on to this part here, we generated the waveform corresponding from the test bench in EDP5. As we all can see, the output is only high when the input is 1110, 1010, and then 0110, and which is the same thing in our truth table as well. So which means the schematic passed the check. As we have verified the design functionality, we proceeded with design rule check (DRC). At first, we had plenty of errors popping up, but as we went through the EDP7 process, we were able to solve all the issues and hence pass the DRC check as well. And the same goes to LBS check as well.
In EDP7, we had to refine and improve our layout. Firstly, as you guys can expect, the layout had too many DRC errors that we had to come out with a completely new layout. After redoing the layout, we had about 37 errors still. We noticed the minimum metal width is 3 lambda, so we changed all the metal width to 4 lambda instead. The error count went down to 15. Next, we readjust the spacing between metal layers. The error count reduced to 14. At this point, we realized that we had put some metals at the surrounding of our layout to make it easier for zooming in and out purposes. As soon as we deleted the metals, the DRC passed. Next, we started doing LVS and it won't run. Then we realized that we did not define metal ports for VDD, ground, and all the inputs and did not define our active region as well. We had to modify our layout to create those metal ports and active regions. After doing such, we have around 12 discrepancies still that we can't get around with. We noticed that our schematic width and length is way bigger than our layout width and length. So we redefine our width and length in schematic and run LVS check on it. This time our design finally passed the LVS check.
Firstly, we weren't able to fully obey to the DRC rules that we planned in our sketching. This is because in our sketching, most of the rules were close to minimum, which we thought would be ideal for our project. But it turns out there were many DRC errors popped up as you guys saw just now. So we had to readjust the rules so that it complies with DRC.
Secondly, all the tasks we did throughout this mini project were divided equally within the team member very early on. Even though we did not make it by the date specified in the table, by doing this, we were able to finish our mini project just on the right time.
The completion of our CMOS layout design project showcased our ability to overcome significant challenges. Despite initial difficulties adhering to design rule check, we systematically refined our design, reducing errors from 80 all the way to 0 through continuous improvement. The collaborative effort with well-defined roles and responsibilities ensured this timely completion. This project not only enhanced our technical skills but also underscored the importance of teamwork and meticulous planning in engineering design processes. And with that, thank you so much.